The lesson topic for this video is solving radical equations. Okay, so the way we're going to solve radical equations is actually a way that we've solved things, other types of equations, including quadratics, in the past. And that is we are going to use the undoing method. So we're going to be undoing the order of operations. And if you remember that the order of operations, we often think of PEMDAS, or please excuse my dear Aunt Sally. And again, we're going to start at the bottom and we're going to move our way up. So we're undoing these steps. We're always going to start by adding or subtracting anything that needs to be added or subtracted. Then we'll multiply or divide. Then we'll deal with our exponent. Now, something we want to add to this is that means the exponent or the radical. Okay, because an exponent actually undoes a radical. So now we're going to add this r here. Some people actually do say PEMDAS, but exponent or radical, and we'll talk about that in this lesson. And then lastly, if there's parentheses. Okay, but the second thing we have to do is we need to make sure to check for extraneous solutions. Okay, this is something kind of new. We've always kind of talked, ever since you started learning about solving equations, that we should check our answer in the original equation. In radical equations, this is absolutely necessary. An extraneous solution is a solution that is an apparent solution. It seems like it should be a solution, but it does not work in the original problem. If we do not check for extraneous solutions, we will not have the final correct answer. Okay, so let's take a look at some examples. Okay, so example 1. Again, remember we are going to use the inverse or the reverse of PEMDAS, including this idea that exponents and radicals undo each other. And then we've got multiply, divide, add, and subtract. So we're going to start here. We're going to work our way up. All right, so the first thing we need to do is add or subtract. And if you look at what's going on in this equation, we have 2 times the square root of 5x plus 2 minus 1 equals 21. So if we're trying to solve for the variable x, again, we have to get rid of everything that's with it on that side of the equal sign. So it's being multiplied by 5, and then 2 is being added, and then it's being square rooted, then it's being multiplied by 2, and then we subtract 1. So we need to do the opposite of that process. So we're going to start by doing the opposite here. We're going to add 1, just like we've always done with equations like this. And we're going to get 2 times the square root of 5x plus 2 equals 22. Now, the next thing we need to do, and our goal here is we need to get this radical part isolated on one side of the equal sign. So again, now we do multiply or divide. Well, we need to get rid of this 2. So we're going to divide this side of the equation by 2, and therefore we need to divide the other side of the equation by 2 as well. Those will cancel. We're left with the square root of 5x plus 2 equals 22 divided by 2, which is 11. Now at this point, the next thing we need to deal with is the square root. All right, so we did our adding and subtracting right here. We did our multiplying and dividing, and now we need to deal with our exponent, which we don't have any exponents, or our radical. And here's our radical right here. So adding and subtracting are opposite operations, and multiplying and dividing are, and so are using an exponent and a radical. So that means we're going to undo the radical by squaring both sides of the equal sign. Okay, and we might want to think about putting each side in parentheses and squaring it. So this side here, what happens is the square root and the square cancel each other out. So the square root and the square are gone. And we have 5x plus 2 left on the left-hand side. And 11 squared is 121. Now we're going to keep solving this like we would any other equation. We're going to subtract 2. Those cancel. We get 5x equals 119. And lastly, we're going to divide both sides of the equation by 5. Which is 23.8. Now, before I circle or put a box around this answer here, I will actually always need to double check that this works in the original equation. If it does not work in the original equation, it is what we call an extraneous solution. So if you plug this in for x in this equation, we'll get, let's see here, 2 times the square root of 5 times 23.8 plus 2 minus 1, and we're wondering, does this equal 21? Okay, so we go ahead and compute that, and we will indeed get 21 equals 21. Again, we can type all of this into our calculator, just be careful to do so, and we will indeed get 21 equals 21. So since this checks out, we do know that our solution is x equals 23.8. One thing I do want to point out is when you are checking this to make sure it works, we do need to make sure that in your calculator, I think the TI, when it brings the square root in, there's a parenthesis already there for you. On the Casio calculator, there is not. You're going to need to have a parenthesis around this whole part of this in order for it to be calculated accurately. So be careful with that. All right, why don't you go ahead and try this next example using what I talked to you about on the previous example, and then check to see how you did on this one. Okay, so hopefully you got x equals 8. If you didn't, you might have forgot this negative right here, this minus sign needs to be brought down. Maybe you just got negative 8, but you should have positive 8. And let's double check that this answer works in our original equation. So we have 17 minus the x value that we just got, which was 8, plus 5 equals 8. And the question is, does it? So 17 minus 8 is 9. So we have the square root of 9 plus 5. Does that equal 8? The square root of 9 is 3, and 3 plus 5 is in fact 8. So 8 equals 8 checks out, and therefore x equals 8 is our solution. Okay, so at this point, sometimes people are wondering, okay, when would a solution be extraneous? So here are two examples that are very similar, and we're going to go ahead and solve them, and then I'll show you how an extraneous solution works here. So the first one, well, all we have here is the square root of x plus 5 equals 3. So we don't have anything to add or subtract. Again, if we think about PEMDAS or PERMDAS, okay, we don't have anything to add or subtract. We don't have anything to multiply or divide. So the first thing we're going to do is deal with our exponent or radical. So we're going to square this side of the equation, and we're going to square this side. The square root and the square cancel. We have x plus 5 equals 3 squared, which is 9. And we're going to subtract 5 from both sides. And we get x equals 4. All right. If we were to check this, we get the square root of 4 plus 5. Does that in fact equal, equal question mark 3? Well, 4 plus 5 is 9, so the square root of 9, does that equal 3? Yes, the square root of 9 is 3. This one checks out. Okay, let's see what happens in the next example. Similar, but the negative 3 on the right-hand side is different. So again, we're going to start by squaring both sides. When we square both sides, the square root and the square still cancel, and we have x plus 5 equals negative 3 squared is negative 3 times negative 3, which is positive 9. And we're going to subtract 5 from both sides, and we get x equals 4. So again, looks like a fine solution, right? X equals 4. But if we go back to the original equation, and we put the 4 in, just like we did on the left, okay, and the question is, does that equal negative 3? Well, we know the square root of 4 plus 5 is the square root of 9, and the question is, does that equal -3? Well, no, it doesn't. The square root of 9 is 3, not -3. And since 3 does not equal -3, we will say that this is an extraneous solution, which means it is not a solution to the equation. It does not work. It is not a solution. Sometimes people get mixed up and they say, yes, it's a solution, it's an extraneous solution. But really, the true answer here is that it's not a solution that will work in the equation, so it does not work for us. Okay, now if you think back to why might that have been an issue, well, if you think about early on in this example, we were saying the square root, let's just rewrite this for a quick second, the square root of x plus 5 equals -3. Well, think about this for a minute. Will the square root of anything ever equal a negative value? The answer is no. A square root will never equal a negative value. So that is why it does not work in the end. All right, so let's go ahead and run through these 2 more examples here, and there's one more on the next screen that I'm going to ask you to try on your own before coming to class. This first one, just going to run through it. Hopefully you can follow with me. We have nothing to add or subtract. We are going to divide by 5 on both sides of the equation. When we do so, we are going to get the square root of 3x minus 1 equals -4. We're going to square both sides of the equation. And we get 3x minus 1 equals positive 16. We add 1 to both sides. We get 3x equals 17. We divide both sides by 3, and x equals, let's see, 5.6 repeating, so 5.667. The question is this a solution to the original equation? 5 times the square root of 3 times 5.667 minus 1. Does that equal -20? Okay. When you compute our work on the left-hand side, we're going to get 20 over here, and 20 does not equal -20. So again, this is an extraneous solution. Okay, so now in this last example we're going to run through, we have a cube root situation. And we're going to do the same thing as we did with the square roots, except for in order to undo the cube root, we need to cube that side, which means we are going to also cube this side. The cube root and the cube cancel, and we are left with 4 minus 3x equals -2 to the third power is -2 times -2 times -2, which is -8. We will then subtract 4 from both sides. We will get -3x equals -12. Divide both sides by -3, and we get x equals 4. So now we need to check that answer to make sure it works. We'll take the cube root of 4 minus 3 times 4 and check to see that it is equal to -2. And it will be. Because the cube root of -8 is in fact -2.